Problem. Here is another overlapping triangle problem. We've got that small triangle here and this larger triangle here. And I can tell that they are similar from this fact. As soon as they tell me that the bases, AC, right, this base here, is parallel to the corresponding base, DE, that's how I know these shapes are similar. And I guess I'll do it with the red one. Because if shapes really are similar, when I stretch it out, those sides have to stay parallel. They can't not be parallel. And if those sides, right, if that base stays parallel, right, if it doesn't slant, if it doesn't slant that way or slant deeper in, if it stays parallel, you can see the consequence of that is that it stays on those rails as we stretch out, and it forces the other sides to stay on track. And that's why that fact tells me these triangles are, in fact, parallel. Are similar. That parallel fact tells me that they're similar. So this is cluing us in that this is similar triangles, and that clues us into proportion. Whenever they're talking about all these lengths, and they're asking you, hey, find the length of something else, that's going to be done with the proportion, especially if they're similar triangles in this, as it is in this case. So let's go ahead and fill in this information. And be very deliberate. When you write in this information, you need to say, is this a side or is it a piece of a side? And AD is not a side. It is a piece of a side. I'm going to write it in just so I don't confuse myself and think that it's the whole side. I'm going to get my check for that. Then they say DB is 12, and that is a side. That's the side of that smaller triangle, 12. And the last thing they tell me is the base. They tell me the base of that small triangle is 4. And I guarantee you, they're asking me to look for the other base. And yeah, that's AC. So we're going to call that X. And already right off the bat, I can start making my proportion. I can say, look, this small base, 4, that's going to correspond to the bigger base. It's just, that's how I see this problem. The bases correspond. And here's where you're going to get trapped. This side here, 12, it does not correspond to 24. It doesn't. Right? That side is not long enough. Right? The 12 goes the entire length. So that 12 has to correspond to the entire, not just here, the entire length of that triangle. So it's whatever that entire length is. So if we kind of backtrack and put everything back, I can tell you from A all the way to B, that entire length is 24, the green thing, plus the red, plus 12. That is the entire length. That entire length is 36. So when we fill in our fraction, right, something from the red triangle, the small one, on top, divided by the corresponding piece of the bigger blue triangle, 36 on the bottom. Just like base of the small to the base of the big, this side on top to the side on top. This is an accurate proportion. It is true, therefore it will allow me to solve for x, and we'll do that by cross multiplying and get 12x. I have no idea what 4 times 36 is, or I do, but it just would take too long. 4 times 36, it's 144. I have done this enough to tell you when I divide both sides by 12, my gut is telling me x is still 12, because I think 144 is a perfect square. But we can check. I'm just going to take my answer, 144, and divide it by 12. And I think I'll get 12. X equals 12. And whenever you get that x equals, you want to make sure that you actually solved for what they were asking. You know, this is 12, and that is what they're asking for, AC. A to C is in fact 12. So you'll say AC is